This is geometry lesson 7.4, overlapping triangles. So the big idea says overlapping triangles in figures can be congruent triangles. So we're going to continue with our triangle proofs. We're going to prove that these two triangles are congruent. We may use the two congruent triangles to then also prove that congruent parts of congruent figures are congruent, just like we did in 7.3. The pictures in 7.4 are just going to be a little more complicated because we've looked at triangles that maybe touch and share a side, but now we're going to have triangles that actually overlap, and they still can share sides and share angles, but the pictures are just a little harder to decipher. So as we take a look at this, I'm trying to prove BA equals DC. So you see BA here and DC here. All right, so if I can prove that these two bigger triangles are congruent to each other, then I know that BA and DC will be equal because those are corresponding parts. Now, when I look at these over here, I've basically taken this and just highlighted those two triangles so you can see it. Some of you may like the strategy of redrawing things and shading things. If you are a highlighter person, you may want to highlight the two triangles so that you can start to visualize what we're looking at. Some of you may want to redraw them separately and mark things up. Now, highlighting I think is a good tool because I just, as I highlighted that, realized that, okay, I did this whole line in pink and yellow. And so clearly those two triangles are sharing that whole bottom piece AC. So that's already a clue for a piece of my proof. So let's get started here. Oops, I don't know why I put a P there. Let's first begin by marking stuff in the pictures that's been given to us, and then we'll run through this. So as we write the given down, let's mark it. So angle D is congruent to angle B, which is here and here. And you can see they've already got these marked here in this other picture here. So I've already got one piece of information given to me there. That's nice. And now AM is congruent to CM. So from here to here, which is not a full side of a triangle. So that does not give me a side here that's equal to CM. You can see that marked over here. What that does do, though, if you look at this triangle that's created from the overlap, this separate little triangle, that is creating an isosceles triangle, two equal sides. So I automatically know that these two angles are going to be equal. So I've already got these angles. I can prove these angles down here are equal. And if you look at it, this angle here is the full angle of the yellow triangle. It would be right here. And this angle here, you couldn't use it for the yellow triangle, right? Because it's not the whole angle, you'd be missing a piece. But this angle here, MAC, that is the whole angle of the triangle that is highlighted here in pink. It would be in there. So if those two angles are equal, I've got this and this. So planning ahead. And then I've also got AC being shared with my reflexive property. So I'll have an angle, angle, side. And then, of course, I can prove my corresponding pieces are congruent. All right, so you can go in any order that you want here. Let's start with the angles. All right, I know that angle MAC is congruent to, so MAC, that's this angle in here. It's got to be congruent to this one, MCA. I'll put two little loops there. So angle MCA. Of course, this was given. I didn't put that down yet. And this one, I know that those are equal because it's an isosceles triangle. That's your isosceles triangle base angles theorem. I'm just going to put base angles. Remember, I'm not really looking for you to be super specific on those. You don't have to tear through all of your formulas and try or theorems and figure out exactly which isosceles one. Just explain that you know those angles are equal because you see an isosceles triangle. Those are isosceles triangle base angles. Okay, if I go back now and I look at what I've got one piece of information. Remember, this is not a side of a triangle. It's not a full side, so that doesn't count. These, though, are angles of the triangle. This angle of the pink and this angle of the yellow. And so now my last piece of information that I need to put in my proof before I can say that these triangles are congruent is that AC equals AC because it's the bottom of this triangle and it's the bottom of this triangle. So AC is congruent to AC. We know that's the reflexive property. Now I have enough information to say that these triangles are congruent. So triangle DAC, and remember I need to match these up. So I went DAC, so it's going to be BCA. And this is angle, angle, side. Once I've proven that the triangles are congruent, any of their corresponding parts are also going to be congruent. So DC, the longer side of this triangle, is going to equal BA, the longer side of this triangle, since we've already proven they're congruent. So now I can say BA is congruent to DC by CPCF. Corresponding parts of congruent figures are congruent. All right, let's slide down. All right, for this one, we were not given those little extra isolated triangles, so we might want to recreate those ourselves. See if it helps. But we are looking to prove in the end, this may help you find the triangles. If you're looking at all this and you're like, I don't even know which two triangles I'm trying to prove. I see lots of triangles. NK equals NJ. So NK is this long piece here. NJ is this long piece here. Now, if we could somehow prove that these big angles at the bottom are congruent, then we know those would be congruent, right? Because it's an isosceles triangle. But based on what we're studying here, we're going to be proving two triangles congruent. And that big triangle is not going to be congruent to another one that's smaller than it. So that's probably not the direction we need to go here. So if you look at NK, it's the longer side of this triangle. I'm going to highlight it in pink. So you can see NK is the longer side of that. And this other triangle on the other side, I'm going to highlight here in yellow, has NJ. Okay, so if I can prove these two triangles congruent that I've just drawn here, I can then say that, okay, the corresponding parts are congruent as well. So let's go ahead and redraw those two triangles. I'm going to start with the yellow one here. So this is N, this is L, and this is J. And we can put markings in them in just a little bit. Let's go ahead and draw the other one now. So the pink one is going to look like this. I think redrawing it is a good strategy. So that's N, and this is M, and then this is K. All right, so as we write things in the given, let's go ahead and mark it in our picture. So we start with NMK, which we can find right here, this one, which is marked in the picture, NMK. And so it's already marked for us, is going to be congruent to angle NLJ. But let's mark it in our secondary picture here. And we also know MK is congruent to LJ. Now I know when I first looked at this one and I saw these markings, I was thinking it was marking from J just to here and K just to here, to that middle part. But when you read it's MK congruent to JL, there's not really any good way to mark it. I don't think there's something wrong with how they did it. You just need to make sure that you can see what it is. And so if it was just given to you in the picture and not in the given, it would be a little confusing, but they've given it to you right here. And so that is the bottom of this triangle and the bottom of this triangle, right? LJ is right here. I'll mark it with two markings just to match this one. And then MK over here. And so right off the bat, I've got an angle matching in these two triangles, and I've got a side matching in these two triangles. So I only need one more piece of information to make this happen. And in these overlapping ones, you always want to be looking for something that they share. There's almost always an angle or a side that they share. Now, we've mostly just dealt with sides that are shared. But this angle up here, angle N, it is at the top of this triangle. And when I flip it around this way, it's at the top of this triangle. So I'm going to use two loops to mark it. But that angle is in both triangles, meaning that it is congruent. And that would give me angle, angle, side, angle, angle, side. So I'm going to go with angle N is congruent to angle N. They share it. It's in both triangles. So that's my reflexive property. I now have three pieces of information, sides and angles. All right, so now I can prove the triangles. I can't get to here yet. So I can prove these triangles are congruent. So I'm going to go NLJ. So if I want NLJ, I got to go NMK on the other side. And that was angle, angle, side. And once I've proven these two congruent, I can now say that NK must be congruent to NJ because corresponding parts of congruent figures are congruent. All right, so that was a pretty straightforward one. Most of it was given to us. We just used the reflexive property to get us the rest of the way. But the picture itself looked very complicated, even though the proof itself turned out not to be too bad. All right, so let's flip it over. So this one called example number 2, even though it's the third one we're doing. We're going to try and prove, now we got lots of triangles here overlapping again, some of them not overlapping, so we got to figure out which ones we're looking at. JL, this whole side, equals KL, this whole side. So again, if we could prove that these angles J and K were congruent, I could prove that those sides are congruent because that's a big isosceles triangle. But based on what we're trying to do here, I don't think that's, again, the direction we're going to go. But it is the side of a bunch of these triangles. So it could be JLM and LNK, or since, again, we're looking at overlapping ones, I'm going to kind of give it away here. It could be this triangle, which overlaps with this triangle. And that is, I'm giving a hint on this one, that is what we're going to be looking at here. And if you look at that there, they hit at this angle, right? And they share this little part of a side, but it's not a full side of either triangle. And other than that, they're not sharing anything. They do overlap slightly, but we're not going to be using a reflexive property in this one because there is no angle that shows up in both, and there is no side that shows up in both. There's a piece of a side, and there's a piece of an angle, but this full angle L, right, is not the top of this triangle. And it's not the top of this yellow triangle either. You kind of would have to piece them together. So no reflexive on this one. Let's go ahead and redraw these as well. So up here we have L down to J over to N. And then over here, we're going to draw the yellow one. So I've got L down to M and over to K. So let's see what we've got here. So we've got angle 3 congruent to angle 4. Well, that is not inside either triangle. I mean, it's physically inside this pink one, right? But angle 3 is not one of the three vertices of that triangle. Angle 4 or angle 3 is not one of the three vertices here. These angle 1 and 2s are. So I'm going to go ahead and put those in those spots. So 1 is the inside here at M, angle 1 right here. And 2 is this inside part here of angle N. So we're going to do some work to get there, but we don't currently have angles congruent to each other. All right, let's see what else they give us. Angle JLN is congruent to angle KLM. So JLN, that is the top of this pink one, so that's this. congruent to KLM, and that is this top angle of the yellow one. So I do now have one piece of information, which means I got to go get two more in this problem. So let's put this down for the given. And let's see where we can go. So we've got these 3 and 4s, which are linear pairs to 1 and 2, right? If we knew what 3 was, let's say we knew 3 was 120 degrees, we know angle 1 would be 60 because it's a linear pair, right? Half a circle. We know those are supplementary. And if angle 3 is equal to angle 4, let's say this was 120, they would have to match. Then angle 2 would also be 60. Now, we don't know that that's true, but we do know that if these are equal and they're supplementary to these two angles, then these would also have to be equal. So even though we don't have the angle measurements, we do know that those are going to have to match up. So let's go ahead and explain that in a proof. We have not done this here before to this extent. So we know that angle 1 and angle 3, and we'll shove it all in one line here, angle 2 and angle 4, we know that they are linear pairs and supplementary. And that's the definition of a linear pair, right? The definition of a linear pair explains that those two angles combined form a line. We know they're supplementary. That's the definition of linear pair. All right, but that hasn't proven that anything's congruent yet. Now, we already know 3 is congruent to 4. We've put that in the proof, so we can use that information. If 3 is congruent to 4, and each one of those is supplementary to 1 and 2, we automatically know angle 1 must equal angle 2. And again, I explained that up here with the 60 and the 60. 3 is equal to 4. We know that. These two and these two are supplementary. So again, we used 120 as an example. Could be anything. But if those two are equal to each other, then the angles that each one of those are supplementary to, they're going to be congruent as well, just like 3 and 4. So how do we explain that? We're going to say supplements of congruent angles are congruent. So let's make sure that makes sense. Supplements of congruent angles, so that's talking about 1 and 2. They are the supplements of 3 and 4. Supplements of congruent angles. We knew 3 and 4 were congruent. 1 and 2 are their supplements. So those two angles also must be congruent. So if I go now and mark those in my picture over here, I now know 1 is equal to 2. That is part of the yellow triangle and part of the pink triangle. All right. So I still need one more piece of information. Right? All I have right now is angle, angle. And with that information, we also know that the third angles are congruent, but angle, angle, angle does not prove two triangles are congruent. So we know the angles all match, but we haven't proven that the sides all match yet. And so what we want to do on this one is use this triangle that's in the middle. It's not actually part of either one. We've just proven that angle 1 is the same as angle 2. So that creates an isosceles triangle here. So if this one equals this one, I know this side has to equal this side of this triangle here in the middle, LMN. And these two sides here are going to actually be sides of the yellow and sides of the pink. So this is LM in the yellow. I'm going to mark it with 2 spots. And then this LN is right here on the pink one. So they're both sides of this little skinny isosceles triangle in the middle. I know it's isosceles because of these two angles, but I've also got this side and this side of those two triangles. And now I've got angle, side, angle. Okay, so now we have LM congruent to LN. We know that because it's an isosceles triangle. I always mess up that word. Okay, and now I have enough information to prove the triangles are congruent. Again, it's angle, side, angle. So I have triangle. I'm going to work from here, here, here. So L, N, J, and then go the same directions on this one, L, M, K. And that's by ASA. And now I can prove this because I've proven the triangles are congruent. So JL congruent to KL by CPCF. All right, and let's slide down to the last one. So for this one, we've also got the picture already redrawn for us. This is a little more complicated with different pieces being congruent, so wanted to get that drawn for you so you didn't even have to mess around with it. But you're not going to actually get that when we're doing real problems. This is just for your notes. You would have to recreate those two triangles, but you can see we've got this skinny one here and this skinny one here recreated. We're trying to prove angle A equals angle C, which are part of those two triangles. So if I can prove this triangle is congruent to this one, then I automatically know A equals C. All right, let's get this highlighted here in the picture. So this one and this one. Now again, as I highlight those and I take a look at what is overlapping here, part of this side overlaps with part of this side, right? The pink and the yellow, and they hit here at F. Now they do share this angle up here, so we get to use that, right? Angle B is up here in the top of the pink one, and angle B is also up here and part of the yellow one. So that we'll be able to use the reflexive there because that's not part of our given. But in terms of these overlapping sides, we don't have any full sides completely overlapped. But take a look at what is given to us, and then we can start to make some assumptions here. So first of all, DB is congruent to EB. So we're not going to be able to use any of these overlapping sides with the reflexive property, but DB, this little piece right here, is equal to EB, this little piece right here. Let's translate that over here. And actually, I'm going to use 3 because over here in this picture, we've already got some things all marked up. So those look like parts of a side, but they're actually the skinny little side of each triangle as well. So if you look at the yellow triangle, yes, that's just a piece of this side of the pink triangle, but it's the full side of this yellow triangle. So which is this piece right here. So this DB is going to equal this EB. So this is where it can get a little confusing when you're looking at it, but that is definitely there. So now we've got a side equal to a side right off the bat. And we've also been given AD is congruent to CE, which we've got marked over here. So it's just this little piece, which is not a full side of one of these big triangles. So right here, AD is congruent to CE. So I'm not going to circle that because that is not a full side of either one of these triangles. So I can't use that as part of an SAS or anything like that. But I'm going to use that to help me get the rest of the way there. Let's go ahead and use the reflexive, get that out of the way. So we know that this angle B at the top is part of both the pink and the yellow triangle. So I can say angle B is congruent to angle B by the reflexive property. Okay, and now I like to circle these and see what I've got. It's a lot easier to see over here. I've got a side and I've got an angle. And now I've got information on this side. I know that this piece is equal to this one, and I know that this piece is equal to this one. So now I need to prove that the whole side is actually equal, and I'll have side, angle, side. And so we'll be able to do that here. Let's talk through it. I know this piece equals this piece. Let's pretend it's 5. I know this piece equals this piece. Let's pretend it's 7. If these two are equal and these two are equal, I know if I combine these, it's 12, and if I combine these, it's 12. So while I don't know that they're 5 and 7, I do know that these two pieces are equal and these two pieces are equal. Therefore, if I add them together, their sum must be equal. So I am allowed to make this jump. We haven't used this in a proof. So let's talk about what this is going to look like. I can say that AB is congruent to BC. And for our notes, I'm going to put something in parentheses right here. So AB came from AD plus DB, right? We did AD plus DB. That's to get the whole AB. That is congruent to these two added together. So BE plus EC. So I'm recreating this, just showing that AB came from these two added together. BC came from these two added together, which we've already shown are equal to each other. So if I add them together, I've got two equal pieces. And that is a very simple one to remember. And actually one we've talked about before, not in these triangle proofs, but that is the additive property of equality. And if you just said the additive property, that is good enough for me. You know that this longer side of the triangle is split up into two pieces that are congruent to the same other two pieces, the corresponding ones in the other triangle. Therefore, the whole side must be congruent. And so now we've got this whole side equal to this whole side. So we've got side, angle, side. We've got enough information to knock this out. So let's call this triangle ABE. Longer side to angle B and then over. So this has to be CBD. We did this by side, angle, side, SAS. And now that I know that this triangle is congruent to this one, I've proven it. Of course, angle A and angle C must also be congruent to each other. So angle A is congruent to angle C. Looks like CC there. And that is CPC.